We're in the pH lab. In this lab, you're gonna understand the pH and what's the buffer's function. So the molecule, if they can release hydrogen, we call it acid. So more H+, more acidic, like hydrochloric acid is a very strong acid because they can release a lot of H+. And to measure how much H+ you have, we're gonna use a pH scale. So the pH scale is the way to measure the H+. And it's a log scale, so definition is minus log of the concentration. Because it's a negative sign, so it turns out when we put the H+ concentration in the scientific notation, you learn it in the metric lab, and after the negative sign, it turns out number is smaller, and that's when you have more H+. So the smaller the pH scale is actually more acidic. And 7 is neutral. So smaller than 7 is acidic, and the smaller the number, more acidic. When the number is bigger than 7, it's basic, sometimes it's called alkaline. And the reason is they have more OH. Or you can say they can take more H+, the same, because OH can combine with the H+. And say, well, this solution have this much H+, and that's why we need the scientific notation, right? You learn in the metric lab. And you take this number, first turn into the scientific notation. 1 multiplied 10 to minus 1, minus 2, 3, 4, 5, 6, 7, 8 to minus 8. And put it into here. So the minus log 10 to minus 8. And minus 8 to minus 8 is 8, pH equals to 8. This is how we calculate the pH. So every time you change the pH number from 1 to 2, 2 to 3, is 10-fold because it's a pH, it's a log scale. So if I give you two concentration, pH 1, pH 2 solutions, I ask you which one is more acidic. Well, of course, you choose the smaller number. I ask you how many times more you have H+ in solution 1 compared with solution 2, and the answer is 10. It's not just 1. So every time you move the scale by 1, it's 10 times. And if I give you two solutions, pH 1, pH 3, and you know still pH 1 is more acidic. And if I ask you how many times more H+ in solution 1 than solution 3, the answer is 10 multiplies 10 equals to 100. So that's the pH scale. And different solution, every solution you can measure their pH by using the pH scale. So the hydrochloric acid, very acidic. Vinegar, acidic. Tomato juice, soda, we talk about soda, still in this range. If it's 7, it's neutral. And in the class, I emphasize the blood. Blood pH is 7.4, so blood is a little bit basic. And these are the basic solution, like bleach, basic ammonia, oven cleaner, very, very basic. So that's the first activity. And we won't do the experiment, but here I put 4 solutions and ask you to guess the pH. It's pretty easy to know, right? So these 4 solutions, distilled water, even though you don't do the experiment, but you know distilled water pH should be close to 7. Carbonic soda, soda is, in the class we talk about the soda, they are very acidic. They're all between 2.5 to 3.3. So just say around 3, right? The soda is acidic. Vinegar, okay, it's about 3 to 4, it's still acidic. And bleach, what's the pH? Bleach is basic. So based on what I give you here, you know the bleach is around this. So the smaller number, more acidic. 7 is neutral. Bigger than 7, basic. So that's the first activity. And the second activity, buffer. So in the class, we talk about buffer. Buffer is anything that can maintain the pH change. We call it buffer. So usually it's a solution, but it doesn't have to be a solution. Like protein is actually a buffer because protein are made of amino acid. Here's amino group and the carbonic acid group. So it turns out both group, one can take H+, one can release H+. So it can work as a buffer. And in this part, we talk about the buffer solution. So the buffer in the class, I explain it. Without buffer, when you add hydrochloric acid into a normal non-buffer solution. And all the hydrochloric acid, HCl, dissociate. So it becomes H plus and Cl. And you have a lot of H plus. You have 3 H plus. So the solution becomes more acidic. Pretty easy to understand. In buffer, so now this is a buffer. When you add 3 HCl, and all the the 3 H plus will be released, but the buffer will take 2. So eventually you only have 1 free H plus. And only have 1 compared with this, you have 3. And when you measure the pH, of course this won't drop that much. And that's buffer's function. So buffer help you to maintain pH. And the same for basic. When you add basic into this solution, it will keep those OH. So the buffer help you to maintain pH. And this is the experiment we're supposed to do. We won't do the experiment, but it's pretty easy to understand. So we have 2 flasks. One is distilled water. The second one is buffer solution. And you start to add hydrochloric acid into both. So you add 10 drops into distilled water and start from pH 7, right? And you add 10 drops of hydrochloric acid into buffer, start from 7. And you found, well, the pH gonna drop. And you add another 10 drops, you keep adding, you found this one pH gonna drop. And buffer, guess what's gonna happen? The pH won't drop that much. So the buffer pH maintain pretty stable. And that's the take-home message. So the buffer help you to maintain pH. Non-buffer, it won't. And here are some practice questions. I leave it for you. You can do some practice, like does a high pH indicate solution is acidic or basic? It's pretty easy to understand this, right? What does high pH means? What low pH means? And when the pH decrease, it's become more acidic or more basic. I'll leave this to you. If you have questions, of course you are welcome to ask me, but these are pretty straightforward. Right? Compare with 2 solutions, pH 2, pH 4 is more or less hydrogen. It turned out the smaller pH more acidic. Of course, yes, more, right? I'm going to choose more. And the last one asks you how many times more, calculate the number. So solution pH equal to 2 and 4. So I ask you how many times more H plus. You know this one is more acidic. And you know the difference between the pH 2 and pH 4 solutions. They are 2. So 2 is 10 multiplies 10 to 2 times. So it's actually 100 times more H plus. You put 100 hydrogen ions compared with this. So these are some practice. Okay, that's it.